Look at Châtelier's principle. Châtelier's principle tells us where would the reaction move to. That is to say, would it move forward? Or backwards. Another thing you need to remember is that a reaction always tries to achieve equilibrium. There are three different factors that contribute in the Châtelier's principle. So first we have temperature, we have concentration, we have pressure, and volume. So let us look at temperature. Okay. So the first reaction I have here is an exothermic reaction. Now, how do I know it's exothermic? It's because of the negative sign that's next to the delta H. Now, exothermic reactions, they tend to release heat. Heat is given out. So if it's giving out, so that means that heat is on the product side of my equation. And it's good if you write down heat. That just makes a lot more sense. Now, let's say for the first question, I were to increase the amount of heat I have here. So initially, my reaction is already in equilibrium. How do I know it's in equilibrium? Because of this sign right here. So it was in equilibrium, but now I increased something in my equilibrium. I increased the amount of heat. Now my reaction wants to achieve equilibrium. It wants to go back into the state it was already in. So my reaction would move backwards. Reaction is moving backwards when I increase the heat on the product side. And the way to, similarly, if I were to, let's say, decrease the amount of heat on my product side, because the heat is on product side, my reaction would move forward to make up for the decrease in the heat. Another way to easily remember or make sense out of it would be that your equilibrium would shift towards side with lower amounts, and then equilibrium would shift towards, sorry, it would actually would move away from side with greater amounts. When I say greater amounts, I mean like greater amount of heat, greater amount of concentration or pressure. Yeah. So this is a really important point, these two. So if you follow the point one, so let's say I decrease the amount of heat. So now on my product side, you have less amount of heat, so your reaction would move forward to make up for the heat because your product side has lower amount of something. But if you look at the second equation here, this reaction is endothermic. How do I know it's endothermic? Because it has a positive delta H. Now, for endothermic reactions, heat is given, like it's taken in, right? So if it's taken in, if it's given, then that means that it's on the product side, it's on the reactant side. So if I were to increase the amount of heat here, now my reaction would move forward because I have more amount of something on my reactant side, so it would move forward. But if I were to decrease the amount of heat on my product side, on my reactant side, my reaction would move backwards to make up for the loss of that heat, following the 2 points I wrote below it. And that's it for temperature. Now we'll look at concentrations, and I just wrote down the above points in better handwriting. So if you have concentration, the idea is the same. Use the points that are written above. So let's say I increase the concentration. Let's say increase the concentration here on my product side for A. I increase the concentration of A. So that would mean that my reaction, my equilibrium would move. So currently it's in equilibrium because of this sign, right? But let's say I increase the concentration of A, that would mean that my reaction would move towards my product side because I'm increasing something on my reactant side. So the side on my product side have less of something. That's why my reaction would move forward. Similarly, if I were to, let's say, increase the concentration of D over here, or C or D, it doesn't matter. If I were to do that, now I have more of something on my product side. To make up for the change, to bring back the equilibrium, my reaction would move backwards because my A and B, my reactant side, have lower amounts of concentration comparatively. So it would move backwards. So like that basically means that because I have more of D, so because I have more concentrations of D, so D is going to get used more. So like my products are going to get used more to make more of A and B because I have a lot of D added into the solution. So it's getting used up to bring back the equilibrium. I could also say, let's say I decrease the amount of B. So if I decrease the amount of B, my reaction would again move backwards. It's moving backwards because I have more of C and D, right? Because a lower amount of reactants now. To make up for that, because I need to bring them into an equilibrium, my C and D would start getting used up a lot more, and then my reaction is moving backwards because I want more of B, because I decreased the amount of B, but I want more B now. My reaction wants, because I want to go back into equilibrium, so I will move backwards. My reaction will move backwards. Just follow the points I've written above. Now we'll move on to pressure and volume. I don't really need delta H's here, but it doesn't really matter. So for pressure and volume, for this question, okay, so first of all, the first thing you notice is the number of moles that you have. So for equation 1, I have number of moles on my product side are 4 moles. On my reactant side I have 4 moles. On my product side I have 2 moles. So which one has lower amount of moles? 2. So my reaction would move towards the lower amount. That means my equilibrium is going to move forward. If I look on the second question, now this is a good one because my products and my reactants are the same amount. So that means that it doesn't matter. Like if I increase the pressure, if I decrease the pressure, it's gonna have no change. Yeah. But also if I have, let's say, volume. So for volume, I would do is that I'll use the equation PV equals nRT. Now because if they ever say like volume is being increased or decreased, so you just follow this equation, right? So if your volume is decreasing, that means your pressure is increasing, and that's how you deal with it. Whenever they talk about volume, make it in terms of pressure. Volume decreasing, that would mean that pressure is increasing. If volume is increasing, pressure is decreasing, and then you solve the questions. Always solve questions in terms of pressures. But we'll look into more examples based on pressures and volumes. So now we'll do some practice questions. So we'll start with following the statements written above. We'll follow them and then solve these questions. For the first one, the question is what happened when I increase the temperature. So because I have an endothermic reaction here, because of the positive delta H, I know that I need to add my heat on my reactant side because I need the heat here when the reaction is endothermic. So if I'm increasing the amount of heat, that means that there's more of something on my product side, on my reactant side. That means that my reaction would move forward because my product side have lower amount of something. So if I look at the above statement, this one, I'll see that my reaction moves towards the side that has lower amounts. So reaction moves forward. Reaction that is favored. Now if I look at pressure being increased, so for here I'll notice that carbon dioxide is the only gas I have, so that is the only gas we can deal with. So that is only gases have pressure, so we're basically talking about carbon dioxide over here. And then I'm increasing the pressure on the product side. So if I increase the pressure on the product side, over here I will know that if I follow the above two statements, my backwards reaction would be preferred. So backward reaction preferred. Reaction moves backward to make up for the increase in the pressure. Now the next question is increase in volume. So over here I need to follow the formula, which is PV equals nRT. So if my volume increases, that means my pressure decreases. So that means that now I have to solve it when pressure is decreasing. So let's say pressure is decreasing. What would happen then? If pressure is decreasing, my reaction would move forward to make up for the loss in pressure on my product side. So forward reaction. And equilibrium would be maintained. If I look at the questions that are below, I will see that, okay, so the question is volume decreases, but now over here, all of these reagents are gases, so all of them have a pressure. But I will notice that my product side and my reactant side both have 2 moles. So no change. I increase the pressure, I increase the volume, decrease the volume, decrease the pressure. Either of that, no change will occur because both of them have the same number of moles. But if I had lower number of moles on one side, then the lower side would be preferred. And the next question is HI is increased. HI, so that means basically the concentration of HI is increased. So if I increase the concentration of HI, my reaction would move backwards because I'm increasing my product side. So to make up for that increase, my reaction would move backwards. So my products I will get more consumed up to make my reactants over here. So yeah, backward reaction. Alright. Now let's say that my H2 is decreased. I decreased in concentration of H2. Now because I decreased the concentration of H2, to make up for it, my reaction would move backwards again. Because, on the above, if you look at the above statements, again, reaction would move towards the side that has lower amount. So I would say backward reaction.